Hello, my name is Lawton. I'm the director of the Containment and Monitoring Institute with CMC. We're down at our field research station. Delighted to be here today with Al Chatney and his crew from Explor. This is a really important technology for the type of work we're doing here. We're developing monitoring technologies to verify the secure storage of CO2 in what are called carbon capture, utilization and storage projects. In our case, we're really just doing carbon storage. So when we inject CO2 underground, we change the properties of the rocks a little bit, and we can actually see that change by seismic measurements. It's very subtle, so we need very detailed seismic methods to be able to see the differences. Because what we want to do is to be able to know where the CO2 is going underground and verify that it's staying where we think it's going. So the technology that Explor has brought out here is really leading-edge seismic technology. We did what's called a baseline seismic survey here in 2014, which was at that time an industry standard project where we had about 1,400 geophones laid out and 1,400 source points over 1 square kilometer. And as you heard from Al, this new survey, we've got 20,000 receiver nodes and 20,000 source points. So that increase in trace density allows us to get very, very high resolution data to enable us to be able to track where the CO2 is going and provide a much clearer picture of what's happening underground. And the way that these systems can be deployed, they're probably very cost competitive compared to with an order of magnitude or more greater trace densities that we're seeing previously. So we're very excited about the technology that's being demonstrated. We're delighted to have the crew here to demonstrate and test in a variety of different conditions. Like today, it's very windy. Normally wouldn't be able to record in days like this, but with this sort of an approach, we're much more flexible in being able to obtain seismic data in a variety of conditions. So this data will be really important for us in order to be able to tell us at this stage of our injection program what's happening in the subsurface and how our storage program is going. So we'll be processing the data in conjunction with Al's group over the next couple of months, and we really look forward to seeing what the images look like of underground. And in particular, we'll get very detailed images right from the ground surface all the way down to way deeper than our reservoir. So that complete, if you think of it, it's a cube of data. We're about to see a cube of data around our site with an incredible amount of detail. So we're very excited about the outcomes that we'll see here. Game changer in many ways. Partly both the flexibility of these nodes, these STRYDE nodes. You could enable us to put them in built-up complex areas. You don't have to have open fields. We have here an open field, but you could use this technology and where a lot of the industrial CCUS operations are going to be developed internationally in industrial parks. So this will be an ideal approach to monitoring in these types of situations.